So like I mentioned, there are two teams. We have the developers who are building the software, and then we have the operations who are also making sure that the software is being used by the end users and also monitoring the usage in terms of traffic and all those things. Now, the question is, are we happy with each other? Are the developers happy with the operations guys? I wouldn't want to say yes or no because these guys are doing two different things. So the developers are doing the programming and all that, and then the operations guys are like more like the IT support guys. Their job is to make sure that the software is running and everything. Now, sometimes these developers will build a software and they'll claim that the software runs. And these operations guys, because they don't know how to do the development or because they are not in that position to do the development, they would just have to assume that the software is properly built and running. But sometimes they get the softwares to the machines that they want to be using or deploy the softwares, and these softwares are not running or working the way they're supposed to. And so I wouldn't say that they are always happy with each other. There's always going to be a tussle. So basically, the operations guy, since we've seen what the developers are doing, the operations guy, they do a lot of things. They make sure that the software is always running. Now, they also have to ensure the flow of the traffic, whether the software is slowing down or something. They would want to ensure all these things. But since they didn't build the software, they can only complain and say, oh, the software is not running properly or something, or there's a bug in the software and all that. But that's not good for the developers. The developers will always be screaming because technically the developers will be saying certain things. Oh, maybe it's not working because of this. Check the operating system you're using. The operations guys will also be thinking that it should be working. And so there's always that challenge because there's no middle ground. These people think it's supposed to be working. The other people are saying that, hey, we're using it, it's not working. And there's always going to be that tussle. The job of the operations guy is to make sure that the operating system on these systems are working properly. They should also ensure these command line things are done properly. They also work on scripts to automate stuff. They also monitor these traffic and also the uptime of these softwares and services. Now, this is the biggest challenge. The developers and operations team, they do two different jobs and they require different skill sets and tool sets. So it's like you have, say, someone who works in a school who is a teacher, and another person who works in a school who works in the canteen. The teacher will go to the canteen to get food, but technically they don't have any it's difficult for them to relate to each other sometimes because maybe the teacher feels that the food is supposed to be out around 4 o'clock because they will be teaching around 4:30, but sometimes the food will not be there around that time. So there's always that tussle, and exactly what happens with developers and operations. One person feels that something is supposed to be working, the other person is saying that it is not working because they're using different skill set and tool set. So one of the biggest challenges is communication because they don't do the same kind of job. It is difficult for them to communicate. Because I'm telling you that the software is working. You're telling me it's not working. Maybe it's because you're using a different operating system to run it compared to what I used to build it. And so there's always going to be communication gaps. Another thing is that, okay, another thing is that for developers and operations team, normally the developers they believe in something else, and the operations team they also believe in something else. So what do I mean by they believe in something else? Developers believe that once the software is running, it should be good for purpose. But for operations team, their focus is not just to ensure that the software is running for everyone to use. Their focus is to ensure that it is working efficiently. So it's not just working, but it's working efficiently. So this is where how DevOps started. Now we have a challenge. The challenge is that one team is having issues and the second team is also having issues with the first team. So at the beginning, there was nothing like DevOps as a job. There was DevOps as a culture. What do we mean as a culture? They decided that, okay, since um, these guys, the developers have a problem with the operations guy, why don't we use the same tools? Why don't we share the same approach? So if I'm doing something, I need to make you guys aware. So if developers are building software, they need to make these guys aware. And so there's supposed to be like a communication between the developers. So there's a bridge. they created their own bridge between the developers and then the operations guys. But the problem was that since the developers would always have to put themselves in the situation of operations, and then operation will have to always put themselves in the situation of the developers, whilst they also maintain their job roles. It was a bit difficult for them to technically evolve because there's still that problem. And so again, there was still communication issue. There was still a gap because the developers are there, the operations guys are there. Yes, I want to understand what you're doing, but I still have a job to do as well. And so these guys were not able to work together. And then boom, here we go, DevOps appeared. So when DevOps appeared, we said, okay, why don't we create like a middle guy, a job role, who would ensure that the developers don't need to have anything to do with the operations guys. Everybody's doing their own. Operations guys are like IT support. When somebody says, "Oh, I cannot start my computer" or something, you just go in and then you help them start the computer or start the software. And so there were two different teams. So when the DevOps guys came in, they say, okay, the developers and also the operations guy, they don't need to know what each other is doing. We need to have a middle guy, like a bridge. And that bridge would have all these technologies that would make sure that once something is developed, it goes through some process. And then once it goes through that process, it comes out. And then everybody can use it. So this is where this course comes in, DevOps. So our job is to learn these tools that would ensure that easily, without having that gap, we were able to create some kind of a pipeline or a tool or some kind of a technology for your team to ensure that the struggle that the developers and operations guys were having, we kind of bridge it. So the DevOps lifecycle, the DevOps approach will be using certain kinds of tools. Instead of installing maybe Windows or some kind of operating system for the developer to work on, and then the operations team, because they are going to be working with the end users. So the end users may be having different computers. Instead of them to think about operating system, the DevOps guy would be that guy to champion the use of maybe Docker containers and say, maybe why don't we use some kind of system which is like a box, and we do all the development in that box. And once the development is done in that box, we ship that box, and that box will be brought into the the user's computer, and then that box will be fitted into the operations computer, and then everybody will be happy. Instead of thinking about the operating system that they are all running, maybe this is running a Mac OS, and this is running maybe another software. The question is, assuming we're just building a software at one time, so we could just have a container and then bring the container here. But no, that's not how softwares are built. Softwares, because we saw the life cycle, we realized that there's also what we refer to as the maintenance stage, which means that there's also an opportunity for any feature which is not working properly to be improved, or any feature which is not existing to be added. And so it's not just a matter of just building the software and putting it here. Now, what if the new feature comes out? Are we going to uninstall the old software and then install a new one? No, that's also a job of the DevOps person. Can we create some kind of a pipe? We create a pipe. Don't forget, these are the tools. That's why they are in the middle. We create a pipe between the developer stage and then, or the developers and then the operations stage. And this pipe is built by the DevOps person. And that kind of pipe can be built using what we refer to as Jenkins, which is this thing. So this thing will create a pipe. So at any point in time, when there's a new feature, that feature will be tested in the pipe, and then that feature will be pushed or deployed onto the system. And so that is the job of the DevOps, to create some kind of a bridge. So it's not just one time, at multiple times. Now, as I mentioned earlier on, one job of the DevOps is to ensure that the software is being monitored, or the system that is built is being monitored. How do we monitor it? We're saying that, okay, we need to be checking the software, but what do we check about the software? How much CPU utilization it's using. So the computers have CPUs and all that. So we want to check how much CPU utilization that is using. And how can we do that? We need a tool like Grafana. So basically, Grafana and what we call Prometheus, they are the tools that help us to get the metrics and also display that in a dashboard. And so with the help of Grafana and Prometheus, we're able to come up with some kind of a dashboard, like a graph, like something which will be monitoring what we're doing on our screens. So instead of going in there and then saying, okay, let me check everything one after the other, you don't have to do that. It will just deploy Grafana or something, and then that Grafana is just going to help us to do that. So it will be just checking the metrics, and then we'll just be looking at on a graph or something, and then we'll just see the dashboard, and we can report to someone and say, okay, this is what is happening on there. So that's one of the things. Now, another funny thing is that every software we build has a lifespan. Softwares will not be there forever. And so since these are containers that we built, assuming this container is what we refer to as the Docker container, we can build one, we can build multiple, but what will happen if the software that we built in that container dies? It means that somebody will have to come and tell us before we go in and then we provision a new one. No, that is the job of Kubernetes. So Kubernetes is like an automated system that will be looking and saying that, okay, at every point in time, these computers should have at least one, say, instance or one version of the software running. So what Kubernetes will be doing, it will be checking the health at every point in time, seeing whether this guy is dying. So when this guy is dying or when this guy dies, automatically it will provision a new one. You don't have to do it over and over and over again. You can use Kubernetes to set it and say, okay, I want you to always ensure that we have one particular instance of the Docker container running. And that is what Kubernetes will be used to do or help us with. And that's also a job of a DevOps, because again, the developers would build, they'll say, we've finished building this software. It's not our job to ensure that the software is running every single time. And that's the job of the operations guy to install it. But the DevOps guys can put some measures in place so that once the software is in deployment or is in operation, what will happen is that if anything goes wrong, the system automatically, what we call self-healing, will automatically heal itself, because there's a way for the system to see that there's something wrong, and we can also provision a new one.